So let's look at the mandate. This is the boring part, the nomenclature. It's the actual paperwork. What it concerns is really the horizon. You have several funding instruments. You have the Excellence of Science, which includes the Marie Curie, you may know of, the European Research Council funding instruments. In the middle, you have this thing, industrial leadership. These are more the small, medium enterprises funding calls. There's a lot of industrial actions. And then you have the societal challenges, which includes the climate change, the marine resources, the transport, the energies, the what else? It's the health. So most of our disciplines kind of fall into this bubble, and the individual fellowships on the initial training networks and the European Research Council fall here. And the mandate concerns all of them. It covers the whole thing. What does it actually look like? These EC documents are horrendous. They go on for pages and pages and pages. I think this one stops at 100, but surely it goes all the way 400. And it is heavy paperwork. The message to take away is that they do like to send threats, so that if you do not comply with this particular mandate, there could be repercussions. Difficult to see how a mandate like this is policeable. The only thing you should be concerned with really immediately is that at review, if the reviewer is aware of the mandate, you will get penalized. And no matter how small the penalty, even let's say it's half a point or a third of a point, in a competitive application rate, that makes all the difference. So another way to read that boring paperwork is this. Just feed into a word cloud and you get a flavor, not very smart way of doing it, but you get a flavor of what they care about. And they care about the results and the articles and dissemination. And now it's an obligation, before it was just a recommendation. They care about the data, and they care that you must do it, right? That comes up a lot. If you look at the actual format of the application, most applications in Horizon, well, actually the template is the same. So it's split into three, and our favorite part is really this, because that's where you're good at something, and that's where you excel, and that's where you have ideas and you can contribute to some kind of problem. But if you are extremely good here and you ignore the other two, you fall. Basically, you need to have some kind of threshold on each of the sections, including those boring ones at the end, in order to pass. It's no use having a great idea if you don't have some kind of strategy and thinking how you're going to implement it, right? And how you're going to disseminate and get the results that you're going to produce to someone who either needs them, clearly you can identify, or some kind of strategy to just get them out to unforeseeable stakeholders. And the mandate concerns really this particular part, maximizing your impact, paying some kind of lip service to societal impact, making an effort to identify potential users, either in industry or in society or related to some kind of societal challenge, so that in a way you're justifying the science that you do. It's not just to satisfy curiosity, to broaden humanity's horizons, but it's also to apply it to something. And this is where you deal with the mandate. If we zoom in, you would see two sections. Impact is expected impact to the work program, and so they want you to show proof that you have read their logic on why they are funding these calls, and to say how your science contributes to that logic. So that's pretty common sense. Then they want you to say something about delivering innovations to market, or having some kind of societal impact. And those things, when you deal with them for the first time, they're kind of daunting and not obvious and scary. If you excel at something at problem solving in the lab, it's not always obvious how you put that to market. So those two issues are critical, but if you look at the actual template, it poses the questions, but it also gives you some of the answers. And this is the encouraging part. How do you maximize impact? Well, they say to adhere to this particular mandate, you don't have to reinvent the wheel. They want a plan for results dissemination and exploitation. So again, thinking of where your results could be of use to whom. Research data management. So when you generate the data, is it just going to stay in the instrument or in an ASCII file or in a USB stick lost somewhere? Or is it actually going to be smarter than that? Are you going to archive it? Are you going to put it in a long-term repository? Are you going to describe it with the metadata so that anybody could come in from another field and say, hey, I could use that? Are you going to publish it in a peer-reviewed data journal and get some citations that way? That way of thinking. You don't have to have all the answers, you just have to show thinking that that data will not be generated and lost at the end of the project. And you have to be convincing. You can't just say, I promise it will not be lost. Right? You have to be convincing and show thinking. And then they want a knowledge strategy for everything you generate. So, how do you do that? And one of our objectives when producing this document was really to keep it as short as possible. Time is expensive. And really the gold nugget, we think, is page 15, where we have tried to give you ready paragraphs to address some of those issues that are mentioned into the template and in the mandate. And this should be discipline agnostic, but there are some examples that might actually be relevant to disciplines. So page 15 is really the one to start from, so that you don't have to reinvent the wheel. On that page we really propose resources in terms of infrastructure. We propose support from the community. When you build a project, you might want to invite a partner that excels at some of these things so that you don't have to start from scratch and you can focus on the research excellence that drives you anyway. So these are just some suggestions. We're not going to read it and go through it. I invite you to digest it in your own time. If you have any questions, all the contacts are on the back of the document. You could use all the social media to get in touch with us, either me personally or the Foster program. We are very active on all the social media, and I'm sure one of us can answer your question. Question?
I wanted to ask, where does science communication fit in open science? I mean, providing all the knowledge you have gained to the public, general public, not just scientists.
Yeah. Good question. Let's see how we answer that in the most shortest and interesting way. If you were to communicate to me what you do without showing it to me, how is that credible? I mean, climate controversies, right? So, one of the things we're trying to argue is that this is the first step towards passive science communication, right? Before you start doing fancy things, before you start doing the film about what you do, before you design interactive outreach campaigns with the public, going into schools, make sure that everything you're about to say can be backtraced and examined by someone else. And you're credible. You check the mandates. It also feeds into the impact factor directly. So when you have that many arguments for doing it, it's difficult to see why people refuse something. But imagine open science and the traditional science communication as a continuum. They're not chunks that fit into each other. They're a continuum of the same information flow from the lab to anybody else who might use it, be it a school or a knowledge-based industry.
Maybe like between public and scientific publication, we miss an intermediate level, which would be transdisciplinary communication. I'm looking up to work in a geography department with people from social science from one side and from environmental studies from the other side. And front, I want to explore. I want to explore because we can read the paper for people from social science, but they cannot read the paper. And in fact, that's a thing, how to communicate with other part of the scientific field.
With other disciplines.
Between disciplines. And something which is I'm more into the field of atmospheric science. But when I read papers, sometimes I'm afraid because you have huge error in statistics, in mathematics. So I don't pretend that in atmospheric science we know a lot and we have to diffuse all the things we are doing. But I think that we have a huge problem of communication between, I don't know, small communities.
Different disciplines.
Different community. For example, here if you go to rainfall measurement, you have people from radar, they begin their communication, but we have not the right DSD, but even if you know atmospheric dynamics, what is the DSD? That's the precise distribution. But you know, but not only atmospheric science, but I think that, and that's the publication logic. We organize ourselves in small community. If of course, I have my own limitation, and if I want to publish, I have to do it in my community. And I think something is missing. It should be intermediate level publication support.
Okay. Interesting.
Yeah, I just wanted to comment to you that in soil science, I'm a soil scientist and we published a scientific paper on decomposition. And then afterwards we've published a lesson plan for teachers, which is also a peer-reviewed publication, but it's it's open access, you can find it online, and that can be used by teachers when they want to apply the method with the schools. And we found that this was a great way for us to bring our science closer to the people that we actually want to be using it.
I think yesterday there was a session which touched on what you're saying, the intermediate publication, and the conclusions were that, of course, we as scientists, we have to be active translators of what we do for society, but also that same instrument could serve to educate other disciplines, to kind of thin the interdisciplinary boundaries. Is that what you're saying? Whether open science can actually thin those boundaries, it probably can passively, not actively, just by availability of all of the research objects. And I've been involved in marine or fisheries research projects, so even in that field you might think, well, everybody is the same community. There's different language, there's different vocabulary of describing the same processes between, for example, people that model and people that observe in the field. So I understand the problem that you are concerned with, and the only way to work on it is to have the same communities in the same room, in the same projects, engaging on the common problems, and then they find common language and they start applying common data standards and using the same software tools. And that's how you, in a way, you smooth the communication between the two micro communities or disciplines. But I'm not sure I have an answer for you.
I was wondering how important is the social media? Is it considered good when you have a Facebook page or you have a Twitter?
So at application, so let's, to reformulate the question, at application stage, if you were to talk about social media, does it matter? Does it help? Yes, it does. The language might have to be a little bit more mature than that. You might have to show that you have a strategy how to deal with the range of social media, or that you have an understanding of the potential of that social media to contribute to controversial issues or public awareness on something that matters, right? So I wouldn't say maybe not an immature, but a naive way of saying it would be, I promise that in my project, if funded, I will use Twitter to tell the public what I do. And that's kind of weak. You need to, it needs to be a little bit more integrated than that, whereby social media is the tool to achieve what you want to achieve rather than the objective, right? If you treat social media as, or the collection of social media as separate tools covering different segments or having different potential, if you integrate them and then you have a clear objective of either reaching a particular stakeholder or target group, and if you show thinking that you know what the range of targets are and you have listed them in some kind of priority, they're not all important, or you don't have the resources to address all of them, so you prioritize your targets and you show some kind of thinking that certain targets use certain communication channels and social media is one of those communication channels, and you plan to use it. One way to argue for it is that by doing so, it helps you communicate your complex science in layman's terms, and that is good for your own training, right? If you show willingness, resources, or otherwise ready to put effort into training yourself, into talking to the media, or talking on controversial issues, or talking to the public, or teaching. In some projects, depending on the call, that is seen as an advantage, right? Sometimes in ITNs, in Marie Curie ITNs or fellowships, there could be criticisms that you don't invest enough of the project on your own training as a young researcher. So you can, it's not just an issue of social media, it's a spectrum of issues that you need to show you understand how they link up. Otherwise, if you just promise one, it's segmented, it's isolated, and it's weak. It doesn't help.
I agree with this statement that the results will be reproducible. But when I think practically, I get confused. Like, suppose I did one experiment, which is computationally very expensive, very tricky, and it generates 100,000 of points. Then how can I think to make my result reproducible to others?
So the question is, if you generate large data sets once, because
very tricky to generate.
Very tricky to generate second time. Right. But that's because it's resource limited, right? For example, let's just for argument's sake say that you're running that particular model, and at the moment it's very expensive to run it again. Therefore, it's not irreproducible, but it's a single point source, right? Well, even more argument to make all of that open, because CPU time, computational time, costs are decreasing and performance is increasing. So even though it may seem irreproducible now, in 6 months' time it might be old news, right? So why wouldn't you make that data set and publish the code behind it in a way that tomorrow anybody can rerun it when the whole system is no longer resource limited?
Just to get the information about it.
Sorry?
Just to give the information, the steps.
How to do it, you mean?
Yeah.
Okay, yes, I understand. I'll probably repeat myself later on, but anyway, so how I would do it is I'll start, for example, if it's a model and model output exercise, I would start with the model And in many disciplines, you actually publish a peer-reviewed paper on the model, how you've designed it, and to explain how it works. I would go the step further and publish the actual code as a peer-reviewed publication. And there's at least 2 open software journals were represented here at this conference, where you could just focus on the code. You have written some kind of scientific routine or code you're making available to the community. The community of experts, software experts, will review it, make sure that it is written in a way that adheres to some minimum standards. They will approve or reject. That gives you a peer-reviewed publication just on the code. Then you can have the research paper explaining how you designed it. A third object would be the actual output, either as a data paper or as a secondary data product, which you could put in a long-term repository and assign a DOI. If you don't know what a DOI is, it's a digital object identifier that is now assigned to pretty much every research publication. It ensures that you can find it at any time, anywhere. So you have, instead of classically 1 publication and some model and with some outputs, now you have 3 research objects that could give you citations and potentially can enter your research evaluation system as a postdoc in your institution. So you're triplicating the things that matter. And somebody could, when the time is right, somebody could rerun your expensive code and simulation and verify it. Not convinced? Okay.